All right, so to finish up the final 4 problems, I hope that you, at this point, recognize the order that I'm going in to establish the different values. I start with the midline, then I go to the amplitude, and then I establish the b value. All right, so in this problem here, again, it's cosine, so if the graph hasn't been moved left or right, we should look at having a similar shape where it begins on the y-axis as well. So beginning with the midline, where the top is at -1, the bottom is at -5, so that means the midline is at -3. The amplitude, which means the distance going up and down below the midline, that's 2. So for the b value, it's b times p has to equal 2 pi. So what we're looking for here is the length of a period. So the cosine graph has a shape like this for a period, a U shape. So the first period would go from 0 to 2 pi over 5. So if I take 2 pi over 5 minus 0, that's 2 pi over 5, and that is the length of the period. It's not the b value. So it's going to be b times 2 pi over 5 equals 2 pi. So I'm going to multiply both sides by the reciprocal of 2 pi over 5. And the reason I do that is because the 5's cancel each other out and the 2 pi's cancel each other out, so the only thing left on the left side is just b. On the right side, the 2's and the pi gets canceled out, so what's left is 5. So the b value in this problem is 5, which means that if I would continue to show the same period of 2 pi over 5, and compare it to the full length of the parent function, which is 2 pi, there will be 5 of those periods in the full 2 pi. So that b value is telling you how many of the periods in the graph you're looking at, the dash graph, it takes to go the full length of the parent function, which is 2 pi. All right, so problem 12, we are now adding in the 4th number. So this time we're going to be left to right. So for the midline, the top is at -1, the bottom is at -3, so the midline is at -2. So we have -2. The amplitude will be the amount going up and down. That's 1. The b value is the period. Now keep in mind that this is a sine graph. The shape looks like this for a period, so I'm looking for that shape. If you look on the y-axis, you'll notice the graph is not going up as the parent function is going up. It is actually going down. So what I'm looking for is, where do I have that shape at? So I can go either start to the left of the y or to the right of the y. So the graph goes up here at -pi over 2. It goes up off the midline at pi over 2, at 3 pi over 2, at 5 pi over 2. So one of those locations you can choose. I'd recommend choosing either the one directly to the left of the y-axis or directly to the right. For this problem, I'm going to choose the one directly to the left. So I'm going to start here. And this would be the length of one period for the dash graph. It's the same shape as the sine graph. So the equation is b times p equals 2 pi. So I need to find the period for this graph here. So we start at -pi over 2. We're going to pi over 2. So the period would be pi over 2. Take away -pi over 2. Got a negative subtraction problem with a negative, so we're going to change to additional positive. that gives me 2 pi over 2. 2's cancel out, which means the the p-value is pi. So it's b times pi equals 2 pi. So if you need to do the algebra, that's fine. So divide both sides by pi. So b is equal to 2. So if I would do the length of 2 pi, it would take 2 of those to do that. Now you'll notice that the length, the two periods there, one purple and green, it starts to the left, slightly to the left of the parent function in blue, and ends again slightly to the left of where 2 pi ends. So the graph's been shifted. So the last number is how much has been shifted, and the number we're going to be using is the number that I chose here to start the first period. I chose minus pi over 2. So that is going to be the shift. So one thing I want you to get in the habit of is, okay, shade that period that you're going to be using. As I mentioned to you, that I could have chosen negative pi over 2. I could have also chosen pi over 2. So if I would have started here, for example, and would have done the 2 periods and ended over here, for example, then my number that would end in for my c value would have been positive pi over 2 instead of negative pi over 2. So the final equation here is y is equal to 1 times the sine of 2 times x plus pi over 2 minus 2. There's a double negative here. We know an additional positive. In problem 13, the top of the graph's at 0, the bottom of the graph's at -4, so that means the midline is at -2. The period, so I'm going up 2 and down 2. The reason I keep going do both of them is to, again, make sure that I put the midline in the correct place, so the amount I go up and down should be the same number. We're doing cosine. It starts on 1 and on the y-axis and goes full 1. You'll notice that this graph here doesn't start 1 above or below the midline, which means the graph itself has been shifted. So what we have to look for is a place where we have that height of 1 to actually shade that first period. So that graph, and 1 here is actually 2 because of the amplitude. So the top of the graph would start here, for example, and would end here. That would be a 1 period. So I tend to go to the left of the y-axis a lot, but again, you could have started at 3 and drew in the period and ended at 7. So v times p equals 2 pi. We are going from -1 to 3, so the period is 3 minus -1. And that double negative, so it's really 3 plus 1. So the period is 4. So it's going to be b times 4 equals 2 pi. Divide both sides by 4. You do the 4 on the left side. And because of that, we can simplify this fraction. And b ends up being pi over 2. So for the last number, since I started at -1, that is the shift. So again, it's really critical that you figure out on the graph where the graph begins and ends for a period. And if you choose the number to the left of the y-axis, it would have been -1 for the c value. If you had gone to the right of the y-axis, axis, then the c value would have been 3. And then you would have be shifting the graph to the right, it's 3. Graph being shifted to the left, it's -1. And both of them are fine. It's just where you choose, how you choose to shift the graph. So the final equation here is y is equal to 2 times the cosine of pi over 2 times quantity of x plus 1, a double negative here, minus 2. And if you had gone the other direction, you would have had y is equal to 2 times the cosine of pi over 2 times quantity of x minus 3. Got to put in 3 instead, minus 2. And then for the last one. All right, so we have a cosine graph, so it starts at 1, and then for a full period it goes back up to 1. So if I look at the midline, so the top of the graph's at 1, the bottom's at top's at -1, the bottom's at -5, which means the midline is at -3. The amplitude is 2. And if you look on the y-axis, the graph is not starting one above, or at the highest point of the graph is actually starting like it looks like a sine graph instead of a cosine graph. So what I'm looking for is on my dash graph, where's the highest point at? So similar to the cosine graph, the highest point is on the y-axis. So the highest point, I have two options here. I'm going to choose this time the one to the right, and that would be here. So this would be 1 period for the sine graph for the dash one. So why didn't I go to the left this time? Well, one reason is because the graph doesn't extend far enough to the left to get back up to -1. So this time I'm using the value to the right. So to find the period, you're going to take the two values for the starting and the ending of the period, which is 5 pi, take away pi. So the period is 4 pi. To find the b value, it's b times p equals 2 pi. I'm going to replace p with 4 pi. To solve this, we divide both sides by 4 pi, which gets rid of the 4 and the pi on the left side, leaving with b. On the right side, the pi's go away, so what I'm left with is 2/4, which simplifies to 1/2. So the b value is 1/2. And then for my shift. And so my value I'm putting in, I'm calling in this is the a value, this is the b, this is the c, and the d. The value I'm putting into the c value is where did I start my graph on the bottom, the dash graph. I started the period at pi. So my c value is pi. Again, I could choose 5 pi if I wanted to go 5 pi, which means I'm shifting further to the right. And if I had the point of the value over here, then it could have been negative value. This one here, the final answer, looks very similar to what's on the screen. Y equals 2 times the cosine of 1/2 times the quantity of x minus pi, close the parentheses, minus 3. Continue on back into Canvas and look for what the next activity is. And you have a first review for your final examination. You have a Delta math activity that goes with this, which is called Unit 6, Lesson 4. It's on assignments. You also have a Delta math assignment due on Sunday. So please work on those assignments.